You've been learning how to solve quadratic inequalities, and now it's time to practice. We have the inequality x squared minus 9 is greater than or equal to 0. The first thing I need to do is make sure that this inequality is in standard form, and ours is, because it has 0 on one side of the inequality. So now what I want to do is think about the related equation, x squared minus 9 equals 0. And we're going to solve this equation. And the first thing that we want to do is we want to factor x squared minus 9, since this is a quadratic equation. And this is a difference of two squares. So I'm going to factor it as x plus 3 times x minus 3 equals 0. And then we're going to set each factor equal to 0 and solve. So x plus 3 equals 0, or x minus 3 equals 0. So by solving this one, I'm going to subtract 3 from both sides. So that gives me x equals negative 3. And then here I'm going to add 3 to both sides. So I've got x minus 3 equals 0, and I'm adding 3 to both sides, and I get x equals 3. So now these are the two endpoints that we're going to, the 2 points that we're going to put on our number line. And while I'm drawing this number line, think about whether or not we're going to have open circles or closed circles on our number line. Since this inequality is greater than or equal to, we are going to have closed circles on our number lines because we want to include the points negative 3 and 3. So I'm going to have closed circles at negative 3 and at 3. The next thing we need to do is test a point in each interval. So we have, I'm going to add a negative 4 to my number line and a 4 here. We actually can see that our number line is separated into 3 different intervals. We have the one to the left of negative 3, the one in between negative 3 and 3, and the interval to the right of 3. So we're going to pick a point in each interval and test it. And I'm going to go with the easiest points. I'm going to, for the first interval, I'm going to choose negative 4. So that's what I'm going to test. And when I test this point, I'm going to plug it back into the factored form of my inequality. So I'm plugging it back into x plus 3 times x minus 3 is greater than or equal to 0. And remember, this is when I'm testing to see if that test point creates a true statement or a false statement. So testing negative 4, I'm going to plug in negative 4 everywhere I see x in my inequality. So I have negative 4 plus 3 times negative 4 minus 3 is greater than or equal to 0. This first parentheses is going to have a negative 1. Negative 4 plus 3 is negative 1. And then negative 4 minus 3 is negative 7. So I'm going to multiply negative 1 times negative 7. That gives me 7 is greater than or equal to 0. Does that make a true statement? Yes, it does. So that interval is part of my solution to my inequality. Okay, so I'm running out of room here. I'm going to have to change papers. Now I'm going to test, actually let me pull this back over. I want to test 0. That's always, for me, it's one of the easiest numbers to test. So let's test 0 in our inequality. So I have, again, let me write it up here, x plus 3 times x minus 3 is greater than or equal to 0. I'm going to plug in 0 where I see x, so 0 plus 3 times 0 minus 3, and I want to know if that's greater than or equal to 0. So this is 3. 0 minus 3 is negative 3, and I'm wondering if that's greater than or equal to 0. I plug in, or I multiply, and I get negative 9 is greater than or equal to 0. Is that a true statement? Well, no, it's not. It does not work. It's a false statement. So this interval between negative 3 and 3 is not part of our solution. I'm going to put an X above it. and I'm going to put a check above that first interval that we checked. So now I'm going to test in the interval to the right of 3, and I'm going to choose 4 to test. So I'm going to plug in 4 plus 3 times 4 minus 3 is greater than or equal to 0. 4 plus 3 gives me 7. 4 minus 3 gives me 1. And I want to know if that's greater than or equal to 0. 7 is indeed greater than or equal to 0. Yes, that's a true statement. So this interval, all of the numbers in the interval to the right of 3 are going to satisfy my inequality. So the last thing I'm going to do, now that I have the intervals that work, I'm going to shade my inequality according to the intervals that work. So, oops. I'm going to put a check above this one. That'll help me remember which ones work. I have my points already shaded, so now I'm going to shade my number line. All of the numbers to the left of -3 on the number line will satisfy this inequality, including -3. And then the same goes for all the numbers to the right on the number line. All the numbers that are greater than 3, including 3, will satisfy this inequality. So finally, let's write our answer, and we're going to use interval notation to write our answer. So looking at the left interval, it extends all the way out to -infinity. Remember, we always have a parenthesis when we use an infinity symbol in interval notation. And then it goes all the way up to 3. I'm sorry, -3. And it includes -3, so I want to have a bracket there. Union that with including 3, extending all the way out to +infinity. And there you have your solution to this quadratic inequality.